Section 8.7. If you're following along at home, we skipped section 8.6. Section 8.7, we are going to now factor some special polynomials. We've already done the distributive property with these special polynomials. We just have to learn how to do them backwards or undo them. So we'll do a reminder of what it was look like back when we did 2x plus 5 times 2x minus 5. The reason why it was special is because both of these factors, they look almost identical with the 2x and the 5 and the 2x and the 5, but if one's a plus and one's a minus, you might remember what happened is we took 2x times 2x is 4x squared, and when we did first outside, we got negative 5x, negative 10x, 2 times 5 is 10, and inside, we got positive 10x. And then last, always be careful, make sure you don't cancel those out. A positive 5 times a negative 5 is negative 25. You're always going to have a first and a last, but inside, outside, a negative 10x plus 10x is gone. So this is when we talked about if you really were on top of things and you recognize that you could shortcut it, you'd be like, oh yeah, this is the full method, not the FOIL method. We don't need outside, inside, because this happens every time. 4x squared minus 25. So now you're going to be given this, and you have to work it backwards into this. Well, please recognize that this should have been a trinomial. It should have been 4x squared, something in the middle, minus 25, but it canceled out. So you're still taking your trinomial and breaking it into two different factors, but we're not making a factor tree, or we're not making a chart over here and trying to figure out. We're just going to take those problems and work them backwards. Okay. If you look at this, before I give you a new one, I'll just walk you through this. How did we get 4x squared? It's because we took 2 times 2, or basically a number times itself. 2x times 2x is 4x squared. How do we get 25? A number times itself. A positive times a negative, and made it 25. So we're close to, if we can find a square root of this number, 4x squared, what number times itself? 2x. When we square root this number, you got to sneak it in there and not try to take the square root of a negative. We know that's not real. The square root of 25 is 5. And then what we have to learn from here is how do we make it into two factors? Make one of the terms plus 5, make one of the terms minus 5. So let's try that. It's called the difference of two squares, so write that down. Difference of two squares. Pause it so you have time to write that. An example would be y squared minus 16. Y squared minus 16. We know that it could have or should have been a trinomial, but the middle term disappeared. If the middle term disappears, that means one of our factors is plus and one of them is minus. How do you decide which one is which? If I square root this number, I get a y times a y. Y times y is y squared. If I square root this number, again, tuck it inside there past the negative, square root of 16 is 4 and 4. Don't believe me? Check it. Distribute that back out using the FOIL method, and I bet you'll get y squared minus 16. The key isn't that this is hard. The key is that you just have to remember the method. 25m squared minus 36. Write that down. We'll break it up into its two parentheses. When we see it's the difference of two squares, that means this number's got to be a perfect square. We can use 25, but we can't use 24. And we can use 36, but we can't use 37. That wouldn't work. So we're going to square root 25m squared and make it 5m and 5m. We're going to square root 36 and make it 6 and 6. And one will be plus and one will be negative. Difference of two squares. The squares are the perfect squares. How about x squared minus 49y squared? Yes, it has a variable on both sides, But luckily, those variables are both squareds, so we can do it. Square root this, square root this. Split the x squared up into x times x. The square root of 49y squared is 7y, 7y, and make sure one of them is plus and one of them is minus. Notice I switched it this time because it doesn't matter. Minus, plus, or plus, minus. That's enough about difference of two squares. Now we'll do perfect square trinomials. Perfect square trinomials. Reminder, this was an old one. This is what we used to do, or this is what we did first. We learned how to find the product of 3x plus 5. And no, there's no such thing as the distributive property with exponents. Doesn't exist. It says, take a number, 3x plus 5, or a factor. Squared means times itself. Take that squared times itself. Watch what happens when you times this by itself. 3x times 3x is 9x squared. There's another perfect square. Plus 15x, that doesn't cancel because this one also is plus 15x. They don't cancel unless one's a plus and one's a minus. But then when we do our last, 5 times 5 is 25. Oh, another perfect square. We start with a perfect square, we end with a perfect square. The only difference between this and the difference of two squares, that didn't cancel in the middle. We have to simplify it. 9x squared plus 30x plus 25. How did we get that? When you take 3 times 5 two different times. 3 times 5 is 15, 5 times 3 is 15. That's how you get it. So we are going to have to practice taking this, working it backwards. We can't do our little t-chart over here and say two numbers that multiply to make 25 and add to make 30. That doesn't work when there's a 9 out in front. That's not okay. So this method isn't going to work. We are going to use the perfect square method, just like we did with difference of two squares. If you square root this, 9x squared, you get 3x. If you square root this, 25, you get 5. We ignore this thing in the middle, this term in the middle. It's there, but we kind of don't look at it because we know that that came from when we FOILed it back together. So square root 9x squared, square root 25, and because this middle number is positive, we have to go plus plus. Let's try that. N squared minus 12n plus 36. Write it down. You know that this is a perfect square, and we're going to do perfect square trinomials because otherwise I want to put it here. You're going to break it into two parentheses, square root the front number into n and n, square root the back number, perfect square, into 6 and 6. We're going to ignore that negative 12 for now. The only thing we need that negative 12 for is to say, oh, those are both negative because that's what the middle term is. N minus 6 times n minus 6. Don't believe me? FOIL it back together. That's not your final answer, though. You must simplify and say, we've got n minus 6 as a factor twice. So your final answer is n minus 6 squared. A little bit more difficult than the difference of two squares, but not too bad. Try this one. 9x squared minus 12x plus 4. We know we need two parentheses. We know this is a perfect square. 9x squared breaks into 3x and 3x. We know that 4 is a perfect square, becomes 2 and 2. We just need to go look at that middle number and make sure we have a negative. On both of them, both need a negative. Final answer, 3x minus 2 squared. And I know, you're already like, what happened to that 12? What happened to the 12? I don't know, FOIL this back together. See what happens. Do the FOIL method. 9x squared. You have a minus 6x and a minus 6x. That's what happened to the 12. Plus 4. Negative 6 and negative 6 is 12. It takes care of itself when you piece it back together. But we're not piecing it together. We're working it backwards. We're factoring. Try these on the dry erase board. You don't have a dry erase board, just try them on your own. See if you get what I got. Pause it, and then put your answer. All right, you should be back. Your answer on this one should be 2x minus 9 times 2x plus 9. If you forgot how already, go back and look up at the difference of two squares. Try this one, 25a squared minus 9b squared. Pause it and come back. And you're back. Did you get 5a minus 3b and 5a plus 3b? Order doesn't matter. You could have done the plus first and then the minus. Those are difference of two squares. Can you do perfect square trinomials? Try this one. Pause it. Did you actually pause it? I don't believe you that you paused it. You're just going to look at my answer. You should try these and see if you get them right. 2x plus 5 squared. How did I get that again? Oh, yeah. I square rooted this number and got 2x. I square rooted this number and got 5. And I took the plus sign out of the middle. Try it. Pause it. Pause it. Come on. Try it by yourself. See if you can get it. All right. You're back. Did you get 4x and 2? And just a little glitch there. Did you get 4x and 2? And did you put a minus sign in between it? Couple more. Pause it. Try it. I'm pausing. And I'm back. You're back. 9x plus 7 times 9x minus 7. Two x minus 1 squared. Pause it. See if you get the same thing. What's the square root of 1? 1. There is a what if. What if? I'm just giving you one what if. What if this happens? This is not a perfect square. This is not a perfect square. So you're like, oh, that's not factorable. Yeah, it is. You might think they're not factorable, but 8 and 18 have a greatest common factor. Their greatest common factor is 2. If I divide this by 2, I get 4. If I divide this by 2, I get 9n squared. Oh, look. Perfect squares. Don't give up on them. You always got to be thinking about that greatest common factor. You do that. Leave the 2 out in front. Square root the 4, you get a 2. Square root the 9n squared, you get a 3n. One of them's plus, and one of them's minus. Do not rewrite the greatest common factor. You just rewrite the factors. All right, I'm done.